As you continue your training, you will be introduced to more advanced flight training, including maneuvering during slow flight. Slow flight can be thought of as any airspeed below normal cruise. However, during your training, slow flight will typically be conducted at an airspeed where any significant reduction in speed or power or an increase in load factor results in a stall indication. You should practice maneuvering during slow flight to develop a feel for the controls at various speeds and power settings, and to learn the relationship of power and pitch to altitude and airspeed. Before you begin the maneuver, check for other air traffic by clearing the area.
There's traffic at 10 o'clock. Let's turn right about 90 degrees.
To transition from cruise flight, first apply carburetor heat and then reduce the power to several hundred RPM below that used to maintain cruise altitude. Remember, as you decrease the airspeed, you must also increase the angle of attack to maintain altitude. During this time, use trim to remove control pressures. When the airspeed approaches the desired value, increase power to hold the assigned airspeed and altitude. As power is added, smooth application of the right rudder is required to overcome the airplane's left-turning tendencies. Then, when attitude, airspeed, and altitude stabilize, trim the airplane to relieve control wheel pressures. The attitude indicator confirms the airplane's high pitch condition, while the altimeter and the vertical speed indicator verify that you're level. At these slow speeds, control response will feel sluggish, although greater control deflections may be needed to achieve a change in flight attitude. You should apply gentle control pressures. Using abrupt movements could result in a stall. While operating in slow flight, any attempt to change altitude solely through the use of control pressures will not achieve the desired results. For example, if you attempt to climb by just increasing the pitch attitude, the airspeed will decrease and the airplane will stall. The correct procedure is to apply power, then adjust the pitch attitude as necessary to maintain the desired airspeed. On the other hand, if you decrease the pitch to descend without reducing power, the airspeed will increase above that desired. The proper way to descend is to reduce power and adjust the pitch attitude. Climbing and descending in slow flight demonstrates that power controls your altitude when you maintain the same airspeed. To turn the airplane during slow flight, the same procedures used at higher speeds are still applicable. However, in slow flight, you must add power to maintain altitude. Whenever you make a turn during slow flight, use shallow bank angles and smooth, coordinated control wheel movements to prevent stalling the airplane during the turn. Your instructor will also have you practice slow flight with various flap settings, so you can see the different attitude and power requirements for each phase of flight. To return to cruise flight, apply full power and slowly decrease the pitch attitude as the airplane accelerates. As the airspeed increases, retract the flaps if extended. After reaching your cruise airspeed, adjust power and trim for cruising flight. Maneuvering during slow flight provides you with a better feel for the airplane in various flight conditions. This will help prepare you for several aspects of flight training, including stalls and landings.
When maneuvering during slow flight, you are flying very near the stall speed of the airplane. But you don't necessarily have to be flying at slow airspeeds for a stall to occur. A stall can happen at any airspeed and in any flight attitude. This program will explain how to recognize an approaching stall with the power off and the procedures for recovering from a power-off stall. Simply stated, a stall occurs when the critical angle of attack is exceeded, causing the smooth airflow over the wing surface to break away. This results in a loss of lift. You practice stalls for two reasons. First, they acquaint you with the stall warnings and handling characteristics of your airplane as it approaches a stall. And second, they develop your skills so you can recover from an inadvertent stall quickly and efficiently with a minimal loss of altitude. Stalls are practiced at an altitude that will allow you to complete the stall recovery no lower than 1,500 feet above the ground. Before starting the maneuver, clear the area. Then reduce power and slow the airplane to the normal glide airspeed. As the airspeed enters the white arc, extend the flaps to the setting used during a normal approach and establish the landing attitude. Once stabilized, smoothly raise the nose to an attitude which will induce a stall. To help determine when your airplane is approaching a stall, there are several cues you should be familiar with. One of these is the decreasing sound as the airspeed decreases. Another cue is the stall warning, which begins around 5 to 10 knots above the stall. This warning may be either a light on the instrument panel, a warning horn, buffeting of the airplane, mushy controls, or a combination of these. As the airplane nears a stall, control effectiveness decreases, and you may feel the airplane begin to shake slightly or buffet. During this time, you still have full control of the airplane, meaning you can still maintain attitude, heading, and altitude. This stage of flight is sometimes called the incipient stage of a stall, or an imminent stall. If recovery is not made at this point, a stall occurs. In a stall, the wings no longer sustain the lift necessary to maintain flight. Once the critical angle of attack is exceeded, the nose will pitch downward. Initiate the recovery by smoothly reducing the angle of attack as you apply full power. As you add power, you'll need to increase right rudder pressure to keep the ball centered in the turn coordinator. Then use the flap retraction procedure specified by the manufacturer. As the airspeed begins to increase following the recovery, gently establish a climb attitude. If this isn't done properly and you increase the pitch attitude too quickly, a secondary stall could occur. Conversely, waiting too long to establish a climb attitude could result in excessive speed and loss of altitude. The correct procedure is to raise the nose smoothly to the proper pitch attitude and climb at the airspeed recommended by the manufacturer. Once you've achieved proficiency in straight-ahead stalls, your instructor will have you do power-off stalls while in a turn. You will use the same procedures as in the previous maneuvers, except you will enter a coordinated turn of approximately 20 degrees before increasing back pressure on the control wheel. Recovery is much like the straight-ahead stall, except that you must level the wings. However, don't level the wings until you've reduced the angle of attack and have added full power. Then, roll the wings level by using coordinated ailerons and rudder pressure. If you're using flaps, they should be retracted, as specified by the manufacturer. Practicing stalls is not meant to increase your ability to stall an airplane, but to help you recognize the onset of a stall and how to prevent it. Or, if one does occur, what procedures to use to minimize the loss of altitude. In addition, by practicing a power-off stall, you'll get a better idea of what can happen during an approach to landing if your attention is diverted from flying the airplane. A power-on stall can occur if you attempt to lift off and climb out at an airspeed below that normally used for takeoff, or if you use too high of a pitch attitude when trying to clear an obstacle. As with power-off stalls, learning to recognize the sensations and visual cues that precede a power-on stall will help you avoid accidentally entering into one. Remember, you should practice stalls at an altitude that allows recovery at least 1,500 feet above the ground. After the area is cleared, reduce power. And as the airplane is slowing to liftoff speed, lower the flaps if appropriate. As the airspeed decreases, increase back pressure to maintain your altitude. When the airspeed has decreased to near liftoff speed, simultaneously add back pressure as you advance the power to the takeoff or climb setting recommended by the manufacturer. The power-on stall is initially performed with the wings level, but to simulate a turn after takeoff, your instructor will also have you enter a 20-degree bank to the left or right. Remember, as you add power and continue to increase back pressure, you must compensate for the airplane's left-turning tendencies by keeping the airplane in coordinated flight. The pitch attitude for a power-on stall will be much higher than for a power-off stall. But, like the power-off stall, you will feel the characteristic buffet just before it occurs. Since you still have control of the airplane at this point, recovery from the near stall condition can be made by decreasing the pitch attitude as you apply any remaining power. Then the wings should be rolled level. When there is no danger of a secondary stall, return to straight and level flight or a climb by retracting the flaps if they were used. However, if you don't recover at that point, the airplane will stall and the pitch attitude will decrease abruptly because of the excessive nose-high attitude. If the airplane is not in coordinated flight when the stall occurs, one wing may stall first, causing a sudden roll as the nose pitches down. If the airplane is slipping to the inside of the turn, the upper wing will stall first. In this case, the airplane might roll in the opposite direction, lessening the bank angle. Conversely, if the airplane is skidding to the outside of the turn, the lower wing will tend to stall first. This results in a steeper bank. If the airplane is properly coordinated, it will pitch down with approximately the same amount of bank. Therefore, you should work to keep the aircraft in coordinated flight as you practice any power-on stalls. As your stall training progresses, you'll be introduced to several aspects of stall spin awareness. Although you are not required to demonstrate spin recovery on your private pilot practical test, you are required to have a thorough understanding of spins and spin recovery techniques. Your training in this area consists of both ground and flight instruction. The ground training portion includes instruction in the areas of stall awareness, spin entry, spins, and spin recovery techniques. Then, as your flight training progresses, further emphasis is placed on stall recognition and recovery, and realistic distractions are introduced during flight at critically slow airspeeds. It's important to remember that actual spin training is not required, and under no circumstances should you practice spins or spin recovery techniques without a certified flight instructor on board. Accelerated maneuver stalls are a variation of power-on and power-off turning stalls. Although not included in the private pilot PTS, your instructor may demonstrate how an airplane can stall at higher airspeeds due to the additional load factors created by a steep turn. For example, in a 45-degree level turn, the airplane's effective weight is 1.4 times greater than in level flight. This means that if the normal stall speed for a particular airplane in straight and level flight with flaps up is 50 knots, it will stall at 59 knots in a 45-degree level turn. Before beginning an accelerated stall, clear the area. Then verify that the airspeed of the airplane is below the published maneuvering speed. This will avoid placing high structural loads on the airplane during the maneuver. Next, roll the airplane into a level bank of approximately 45 degrees and firmly increase back pressure on the control wheel to initiate a stall. Normally, you will recover at the first indication of a stall by releasing back pressure while simultaneously adding full power. Then, use the flight controls to keep the airplane coordinated as you level the wings. A crossed control stall is most likely to occur during a poorly planned and executed turn from base to final approach, and is often the result of overshooting the extended runway centerline during the turn to final. Even though flight proficiency in a crossed control stall is not required, it will be demonstrated to you by your flight instructor. The important thing to understand is not how to perform the crossed control stall, but to be able to recognize its onset and the procedures necessary for a safe recovery. A crossed control stall will occur when you apply aileron pressure in one direction, rudder pressure in the opposite direction, and use excessive elevator back pressure. Stall should be practiced at an altitude that will allow you to safely complete the stall recovery no lower than 1,500 feet above ground level. For this demonstration, we'll check the area for other traffic, reduce the power, then maintain altitude until the airspeed approaches the normal glide speed. Flaps should not be lowered during this demonstration because of the possibility of exceeding the airplane's limitations. Once the glide attitude and airspeed have been stabilized, roll into a medium bank turn to simulate a final approach turn with an overshoot to the center line of the runway. Continue the turn while applying full rudder input in the direction of the turn. Maintain the bank by applying opposite aileron pressure to stop the overbanking tendencies, while slowly increasing back pressure on the elevator to keep the nose from lowering. When the airplane stalls, release the pressure on the flight controls and then increase the power as necessary to return to straight and level flight. In a crossed control stall, the airplane may stall with little or no warning. The nose may pitch down and the inside wing suddenly drop. The airplane may continue to roll into an inverted attitude. This is usually the beginning of a spin and can be very dangerous at lower altitudes. Early recognition of the characteristics of a crossed control stall is very important because recovery may be impossible due to the altitude needed for a safe recovery. The demonstration of an elevator trim stall will show you what can happen when full power is applied during a go-around from a normal landing approach, a simulated forced landing, or immediately after takeoff with an improperly set takeoff trim setting.
Whenever we're practicing stalls, John, one thing you've got to remember, according to the PTS, is that we must recover from a stall no lower than 1,500 feet AGL.
Even though flight proficiency in an elevator trim stall is not required, it will be demonstrated to you by your flight instructor. The important thing to understand is not how to perform the elevator trim stall, but to be able to recognize its onset and the procedures necessary for a safe recovery. You will also learn the importance of making smooth power changes, how to overcome strong trim forces, and how to maintain positive control of the airplane in a go-around environment. After clearing the area for other traffic, slowly reduce the power. Lower 1/2 to full flaps. Then set the power to idle. Maintain altitude until the airplane slows to the approach glide speed. Once established in a glide, simulating the final approach path to the runway, smoothly advance the throttle to the maximum allowable power as you would in a go-around.
To recover from the approaching stall, apply positive forward control pressure to lower the nose, maintaining directional control with aileron and rudder pressure. Maintain forward pressure until a normal climb airspeed and attitude can be established. Then retrim the aircraft to remove excessive control pressures. It is imperative that a stall does not occur when full power is applied during a go-around from a normal landing approach, a simulated forced landing, or immediately after takeoff with an improperly set takeoff trim setting, because the amount of pitch change and altitude needed for a recovery may be inadequate. From this demonstration, it is apparent that stall recognition is important, and prompt recovery procedures should be implemented immediately to prevent a fully developed stall condition.
After gaining proficiency in stalls, you will be introduced to more advanced maneuvers, such as constant altitude steep turns. This maneuver consists of a constant altitude 360-degree turn with a bank angle of 40 to 50 degrees. The Practical Test Standard, PTS, requires that you be able to turn in both directions. Steep turns help you develop coordination of pitch and bank while maintaining altitude at a constant power setting. They also develop smoothness, orientation, and division of attention. Before you enter the maneuver, make sure there is no conflicting traffic in the area. To maintain orientation, select a reference point parallel to your flight path. Section lines, roads, or a prominent landmark on the horizon are all good reference points that help you determine the starting and ending points of the maneuver. Begin the maneuver with the airplane stabilized in straight and level flight at an altitude that will allow you to complete the maneuver no lower than 1,500 feet above ground level. Your airspeed should be at the manufacturer's recommended speed, or, if none is given, at or below maneuvering speed. Roll into a 45-degree bank turn with coordinated aileron and rudder pressure. This bank should be smoothly established at a moderate rate without rushing. As the bank steepens, you will need to increase back pressure and add power to maintain level flight. If you do not maintain the proper pitch attitude, the aircraft may enter a steep descending spiral. The natural reaction in this case is to increase control wheel back pressure, which only tightens the descending spiral and increases the possibility of an accelerated stall. If you're losing altitude and the pitch attitude is low, decrease the angle of bank slightly, then bring the pitch attitude back up to level flight and return to the desired bank angle. When you roll out of a steep turn to a designated heading or to your reference point, use the same procedures as for shallower banks, but initiate the rollout approximately 20 degrees before reaching the desired heading. As the bank decreases, reduce back pressure to maintain altitude and adjust the power to return to cruise. If you use trim during the turn, the last step is to relieve control pressures by retrimming the airplane. As you gain proficiency in steep turns, you may learn to continue from one turn to another without hesitation between the two. The back pressure held in the first turn is reduced during the rollout, then reapplied as the angle of bank increases in the turn to the opposite direction. During this maneuver, you will most likely experience an overbanking tendency. This is due to the wing on the outside of the turn traveling a greater distance than the inside wing. Since it is traveling farther, it has a faster airflow. As more air passes over an airfoil, more lift is produced. This increase in lift on the outside wing causes the airplane to roll beyond the desired bank angle. To counter this tendency, you must apply slight aileron pressure opposite the direction of turn. In addition, Because the tail of the aircraft is located aft of the center of gravity of the airplane, it does not track in the same arc. To streamline the fuselage, you need to apply rudder pressure. As you practice steep turns, you will begin to gain confidence in controlling the airplane while your attention is diverted outside. Developing this important skill helps you progress easily into the more advanced ground reference maneuvers.